New Zealand. We're a beautiful country, and we are also a unique country. Our vast, clean, green, pristine, and untapped environment gives and facilitates the rise of goods and products which are not only specifically unique, but can only be produced at a quality signature and identifiable to that of New Zealand. However, the primary industries, which are the main producers of these goods and products, are currently in the middle of a sustainability crisis. There are many issues which affect our primary industries, which coinciding with an increasing demand for our goods and products means that in the future, demand will eventually exceed our capacity to provide. After much research and looking through endless amounts of statistics, I've managed to isolate all the issues affecting our primary industries into 4 key problems which I believe must be addressed in order to ensure the sustainability of these industries. With the accumulation of these 4 main issues, our primary industries, in my opinion, are unsustainable for the long-term future. In order to ensure sustainability, I believe change must be made, and change requires innovation. But it can't just be any old innovative process you throw into the pot and hope a result comes out. Any innovation introduced must be able to provide and address these 4 key problems in order to ensure future sustainability of our primary industries. And it is on this thought, I believe, unmanned robotic technology to be that future. So what is an unmanned robot? Well, an unmanned robot is essentially a machine or a vehicle which can operate without the direct presence of a human operator. Broadly speaking, there are 2 types. Remote control robots are operated from a remote control module at a distance by a human operator. Autonomously controlled robots can operate with 0 to minimal input from a human operator and can work independently using a combination of external sensors to sense and gauge its external environment and onboard computer technology. Your basic unmanned robot will consist of 6 main key parts. Firstly, every unmanned robot must have a power source of some kind. This can be either through a standard lithium-ion electric battery, a fuel tank for more robust machines, and if the robot isn't expected to move around a lot in its constrained environment, may even be fixed to a wall through a simple power socket and plug, such as a manufacturing robot. In order to convert potential energy into the power source into usable mechanical energy for work and movement, every robot must have some form of a motor actuator system. Basically speaking, there are 3 broad types available: hydraulic, electric, and pneumatic, each with their own unique advantages and disadvantages, which any robotic designer must take into account when designing their machine in order for optimal use. The mechanical energy from these actuators will then feed into a series of movable parts, which can be any combination of robotic arms for manipulation, wheels and treads in order to traverse across a variety of terrain, and propellers for stabilized flight. Every unmanned robot must have some form of sensor technology. Internal sensors allow an unmanned robot to coordinate, calculate, and balance its own movement in real time, similar to how we coordinate, calculate, and balance our own movements in real time. This is particularly important for robots which move around a lot in an environment due to the need for balanced distribution of forces and stability of movement. Autonomously controlled robots will rely on a degree of external sensors, which can be infrared, ultrasound, or spectral or multispectral sensors in order to gauge a variety of information from their external environment, where it's processed by their onboard computers in real time and an appropriate output command determined based on the instruction set. And of course, controlling the entire process is onboard computers, which are devices capable of executing a program or an instruction set. This device is essentially the brain of the robot and is responsible for all programming, execution, and communication to and from receivers. Linking the entire system is an electrical circuit network, which is not only responsible for allowing a flow of energy to and from components, but also serves as a vital on and off switch for components in the machine. And here are a few examples of unmanned robots. This is Precision Hawk's smart farming drone, which is designed to provide farm managers a variety of useful and easily accessible intel, which include aerial surveillance photos. And this is New Zealand's own in-development, multi-purpose orchard robot, which is designed to conduct a variety of time-consuming and energy-intensive tasks on sites such as the picking of fruit, the pollination of flowers, and even the spraying of pesticides. So that's all good and all, but how do unmanned robots benefit our primary industries and therefore our export economy? Well, In the agriculture and horticulture sector, they can be used for a variety of time-consuming, energy-intensive, and labor-intensive tasks, which are not limited to the examples shown here. This is particularly important as the agriculture industry is suffering for workers in these particular parts, which means demand will eventually always exceed capacity. Aerial drones, like the Precision Hawk, can provide a variety of useful information to farm managers to enable optimized, better, more precise, and more efficient decision-making. And what's better is that the Precision Hawk can be accessed through simply your smartphone or a tablet, which means you don't have to learn an entire new set or system of remote controls to operate it. And here is an example of a multispectral output produced by the Precision Hawk. The red areas show areas where crop yield is low, yellow is where areas are satisfactory, and green is where crop yield is good. In order to obtain this type of information using traditional means, it would take a farm manager a lot of extra effort, extra time, and extra money, or they wouldn't even have access to this information at all. With a drone, just a single flight, a farm manager will then be able to use this type of information and better strategize, plan, and concentrate their rejuvenation efforts instead of simply blanketing their whole field in chemicals and substances. Let me tell you the story of a Canterbury farmer named Alvin Reid. Alvin and his wife regard themselves as forward thinkers, and having to run a dairy farm of 4,000 cattle, you can't blame them for seeking technological, more stress-relieving alternatives. The entire family runs a robotic milking setup which relies on a variety of external sensors and movable parts in order to automatically detect, scan, and milk cows without direct human intervention. Ever since its implementation, it's been reported that there's been a tremendous reduction in workload and stress for the family and the workers on site. And although initially costs an extra $300,000 to $400,000 more, can save one full-time unit of labor over the farm, which is very essential in the long run. Alvin was even quoted as saying, "The cows essentially milk themselves." What's better is that the entire process of monitoring, milking, and maintaining all 4,000 cows can be controlled in a single room with a series of monitors and a keyboard. Alvin's story is one that I hope many New Zealand farmers will take inspiration from, replicate, and seriously consider the advantage unmanned robotics not only has on their field of practice, but also on their daily lives. The forestry sector is another big signature sector in New Zealand, with the primary concern being the cutting of trees on an inclined slope, having a death rate of 20 times greater than your average New Zealand practice. Fortunately, this John Deere 909 tree cutting machine not only aims to reduce deaths, but also to increase production, and as you can see, is far more than capable of cutting trees on a steep terrain. Ever since its initial test run in the New Zealand forestry sector, it's been a significant decrease in fatalities per year that has been reported. And coinciding with this, there has been an increase in production from 200 tonnes of wood per day to 350 tonnes of wood per day, which is a significant positive margin. What's better is the entire process, the entire machine, is entirely remote controlled from a distance, meaning no human worker is placed under unnecessary risk. It was even reported as being a world leader in death reduction by the FRR chief executive, Russell Martin. Simultaneously, our old friend, the aerial drone, can provide a variety of useful information to forest managers, which include 3D spatial mapping outputs. And what's so useful about these outputs is that they are very accessible and very quick to get. Also very effective and very cheap. Using this 3D spatial mapping output, a forest manager can gain information on tree yield over time, potential areas under effect by pests, and even forest fire control, which is a big issue in New Zealand. The mining sector is another big one in New Zealand. It is a frontier and exciting sector, but it is also the one that pushes New Zealand's health and safety policies to its limit. Once again, unmanned robots, I believe, can be used to field a variety of time-consuming, intensive, and dangerous tasks on site in an industry that is already struggling to source workers. Let me bring up a bit of a case study. In the Pilbara mines in Australia, you may have heard of this, a series of driverless, autonomous, GPS-integrated trucks were used to carry deposits, wastes, equipment, and even workers across long distances of mine infrastructure. These trucks communicated via radio signal to a land tower, which would then communicate via radio signal to a series of industrial GPS satellites, accurate to the millimeter. The entire system ensured that the trucks, in real time, stayed on their projected path relative to their current movement. Ever since the integration of these trucks, There's not only been a reported significant increase in productivity, but also the demand for workers decreased in this sector, which is a big issue due to the lower capacity that we can provide workers to this industry. Which comes to show just how effective a fleet of unmanned robots can be. In terms of health and safety and integrity inspections in this sector, I believe unmanned robotics have a key part to play, especially when it comes to preventing incidents such as the Pike River mine disaster. I believe had unmanned robots been used to be equipped with sensors that could detect structural disabilities and also detect hidden pockets of methane, which were both primary causes in the first explosion, then they could have taken this information where the inspectors would have reviewed it in the office, potentially have picked out this weak spot, and applied the appropriate remedies, which could have been remedying the structural defect and draining excessive pockets of methane, and thereby having potentially have prevented this whole disaster from occurring. And of course, how do we answer the final question? How do unmanned robots stimulate a new generation of Kiwis, particularly those trained in the STEM fields, to enter our primary industries? Well, we are providing the opportunity to work with world-class innovative technologies, see them being applied on an industrial scale, as well as working with the overarching aim of making New Zealand a more safer, more robust, more efficient, and more clean workplace. Wouldn't you want you and your children to work in such an industry? And lastly, I believe unmanned robots are not simply limited to use in our primary industry, with uses ranging from environmental research, search and rescue, construction and surveying, all the way to the delivery of your own personal Domino's pizza. I believe unmanned robots have a key part to play in our society and are our future. But the question is, how fast do we want to reach that future?
Thank you, Roland.
Yeah, hi, thank you. I can't help thinking that if humans were smart enough to monitor the unmanned robotics at Pike River, they would have been smart enough to prevent the disaster happening in the first place.
Well, you see, in my opinion, that what happened wasn't necessarily a issue of intelligence. It was more necessarily an issue of humans being limited in that regard. Because if you think about it, in a large infrastructure tunnel, such as one of that size, where visibility conditions are low, and an inspector only really has a flashlight and his bare eyesight to look at, then obviously, even the slightest defects can be overlooked, or the inspector could have simply just seen it from a distance and be like, oh, that doesn't look like anything, right? But if you use, for instance, I'm just talking off the top of my head here, you used an aerial drone to fly to the roof of the defect, where the main defect was, then they would not only be able to have a better visual representation of what's going on, but they would see this up close, get information they couldn't get while they were down on the ground, shining a torch up into a cavity that was about 10, 20 meters high. And they would take this information, be more well informed, and suddenly make a call saying, oh, we've got a problem here. 29 workers are going to die tomorrow, because if this roof collapses, then the methane will seep into the main mine infrastructure and be ignited. So, in my opinion, to answer your question, it wasn't a matter of intelligence. It was more a matter of being limited as a person.
I also wonder whether, if you're prepared to put that much money into that sophisticated a system, a few more people on the ground would have also prevented that disaster. In other words, I'm sorry to interrupt. In other words, are you not putting a bit too much faith in machinery?
That argument can also be reversed, as in, why are we putting so much faith in... I'm not saying humans are bad, me being human and everything, but there are some things that robots can, in my opinion, do more efficiently and more effectively. And in that case, I believe, unmanned robotic technology would have been worth the investment. I mean, how much is 29 lives? How much of a price would you put on that many people? If you use unmanned robots, they can without a doubt pick up structural deficiency or excessive pockets of methane, which were both the primary cause of the first explosion, therefore having provided that vital information to the inspectors, who obviously by themselves were limited by their senses as people. Therefore having potentially prevented this whole disaster from occurring.
A lot of chat going on about automatic vehicles, electric vehicles, driverless cars. Driverless cars is what I'm trying to say. Thank you. Are you enthusiastic about those?
Not at all.
Why?
One reason for that is unmanned robots are still, a lot of the research going into this type of technology is still in the development phase. And the main type of area that this research is being developed is automation and the movement of vehicles in a very complex environment. The thing with driving in a car on a road is there's so many factors that have to be taken into account that you simply can't just be like, oh, here's the problem, and let's just make a solution. Once you put the solution in, a whole host of other problems arrive. Like, you must have heard of the crash using a driverless car that happened a while ago, don't know how far back it was, where a driverless car crashed straight into a truck because it couldn't recognize, due to the white painting on the bottom, it thought that the elevation was part of the sky instead of being an actual vehicle on itself. In terms of that type of use where a lot of human judgment is required, I still believe unmanned robots have a lot to go. And that being said, there are a lot of things that they can be useful, like moving around in a constrained environment. Say, for instance, through rows of crops is a very simple procedure. All you really need are pressure or external or ultrasound sensors to determine the boundary of movement. And that's essentially my answer.
Thank you.
Yeah.